Okay, good morning. Let's start with amplifier. I think you are quite accustomed to this term amplifier. By the way, what is an amplifier?
Sir, input device that maximizes a signal.
Your definition is a bit wrong because it cannot be maximizes.
Not
Maximizes.
maximizes,
Set
increases the.
increases its amplitude, its intensity.
Yeah, fine. What are the different types of amplifiers? Do you know?
Positive and negative.
Huh? What is that? Somebody said positive and negative. Who is that?
So I said.
I cannot get it. Who are you? What's your name?
Sir, Parvez.
Parvez. Now the thing is that cannot be positive or negative. There broadly 4 types of amplifiers. One is where the input is voltage, output is also voltage. That is called voltage amplifier.
Voltage amplifier.
Voltage amplifier. There is another type where the input is current, output is also current. That's called the current amplifier. If you have one amplifier where the input is voltage, output is current, there it is called I didn't get you.
Voltage dependent current amplifier.
No, not
transconductor.
Yeah, transconductance amplifier. And if it is your input is current and the output is voltage, then it is called transimpedance amplifier. So these are the 4 broad areas of amplifier. Now let us consider on only the voltage amplifier. That means in our case, the input will be voltage, the output will also be voltage. Say for example like this. Let the gain of the amplifier be A. So what will be your V naught? It will be nothing but A times Vi. Is it not?
Yes, sir.
Yes, sir.
Now, in case we assume the value of A to be 10, if my applied input voltage is 0.1 volt, in that case, my expected output voltage is
1 volt.
1 volt.
1 volt.
Now, where from this extra voltage is coming? What is the source of that?
DC supply.
That's coming from the DC supply voltage. So that means every amplifier must be equipped with some DC source. That is supposed to be the DC supply source, where from the enhanced, I am using the term enhanced output will be derived from that particular DC source. If the input is 1 volt peak to peak AC, the output is expected to be 10 volt peak to peak AC. So, but the input, the source that you are having, that is one DC voltage. Say this is DC plus 20 volt or plus 15 volt or whatever it is. So the output voltage is supposed to be coming from the DC source. But what is the nature of the output voltage here? AC or DC?
AC.
AC. So basically, what is the purpose of the input signal? The input signal is having effect on the output in such a manner that though the output voltage is coming from the DC source, basically that output voltage is as if getting modified or some sort of modulation, though I should not use the term modulation in true sense. rather I can say that the output voltage is getting the waveform nature as that of the input voltage, but this source of the extra energy or the extra voltage, that is nothing but your DC. So though the input, the source is DC, but at the output I may get AC or some sawtooth waveform or some triangular waveform, whatever it is, provided that output is getting the nature from the input signal nature. So the VI nature will have direct effect on the output, so that the output nature will be the somewhat similar to the input voltage nature, but with larger magnitude values. Those the larger magnitude levels, they are coming from the DC. Now I have probably I have explained this thing earlier also. How many DC sources should be there for any amplifier?
2.
I didn't get you, Baba. Rajiv?
Set 2.
2. So one is called
Plus
the
V set.
plus V set,
Plus V set or minus V set.
and the other one is called the minus V set. Now, what is the significance of the term plus V set and minus V set? That also we have explained earlier. Why is
So the
that-
maximum voltage that the DC source can provide.
to recapitulate, let us go for this particular example itself. If Vi is 0.1 volt, say 0.9 volt, 1.1 volt minus 1.2 volt. So for 0.1 volt, what will be the required output?
1.
1 volt. And what will be the actual output? 1 volt. For 0.9 volt input, what is the required output as per my this equation?
9.
9 volt. So what will be? Acha, by the way, I have not mentioned about the plus minus Vset levels. Say let these two voltage levels be plus minus 10 volt. So plus 10 volt and minus 10 volt. Those are the two DC sources that we have given. So here I'll be getting the 9 volt. So when the input is 1.1 volt, what is the expected output?
11.
11.
But what will be the actual output?
10 volt.
Because my positive output voltage should be coming from the positive DC source. Now the value of that positive DC source is plus 10 volt. So I cannot get anything beyond that voltage level. So my output will be clamped to the 10 volt level. Similarly, when the input is minus 1.2 volt, what is the expected output?
Minus 12.
Minus 12 volt. But this negative output voltage must be coming from, must be derived from the negative DC supply that I have provided. What is the level of the negative DC supply? The minus 10 volt. So I cannot get at the output anything beyond minus 10 volt. So the output will be once again here clamped to minus 10 volt. So rather what I find is the output is getting saturated at this plus 10 volt and at this minus 10 volt. That's why those two DC voltage sources are most of the time termed as plus Vset and minus Vset levels. Okay, and this transfer carriage also I have explained probably.
Yes.
Output will be contained within these two levels, plus Vset and minus Vset. Here I am plotting Vi, here I am plotting V0. Now, if your value of A is 10, in that case, when and this plus Vset level is plus 10 volt, and this is minus 10 volt. So when the input is plus 1 volt, the output is supposed to reach the plus 10 volt Vset level, and when the input is minus 1 volt, output should reach the minus 10 volt. So this is going to be the assume that this is a one state line, though my line is no longer near to the state line. And beyond this +1 volt, when the input is more than +1 volt, the output will be
10 volt plus 10.
10 volt plus 1.
similarly here also the same thing. So that means in this transfer characteristics, I have three distinct regions. One for the input voltage range +1 to -1 volt. So there the output is directly proportional to the input. Or this equation represents the equation of a straight line with a slope A. So this particular range, -1 volt to +1 volt, that range is called the linear region of the transfer characteristics for this particular amplifier. For specific to this particular amplifier, the linear region exists for the input voltage range of -1 to +1 volt. Beyond that, there are two distinct non-linear or saturation regions. One is the plus VSAT region or the positive saturation region. The other one is the negative saturation region. So these are the three distinct regions of the transfer characteristics of any amplifier. Now, if the gain becomes more, what do we expect for a fixed plus minus VSAT level? If the gain becomes
Slope
more,
increases.
the
লোকটা বেশি হবে।
slope-টা বেশি হবে, তার জন্য আবার আরটা কি পাবো? না,
Linear
the
region ছোট হয়ে যাবে।
region over which it is operating the linear, it is representing a linear characteristics will be shortened. Isn't it not? If the gain becomes
Yes.
20, in that case, the input voltage range for which the amplifier operates in the linear region will become plus minus 0.5 volt. ঠিক বললাম তো না? হ্যাঁ। If the gain becomes 20. So the higher the gain, the smaller is the linear region over which the amplifier operates in the as one amplifier. So in this region or in this region, will the this circuit operate as an amplifier?
No, sir.
It will operate as an amplifier only in this region. So that's why to have amplifier action, I must try to ensure that the input voltage is chosen in such a manner that the amplifier is operating in the linear region. If the input voltage goes beyond that linear region, the amplifier circuit will not operate as an amplifier. In that case, the output will be saturated, either plus VSAT or minus VSAT. This basic concept is essential for whatever type of amplifier you are using. Now, I think you have heard the term difference amplifier also in your electronics class. Have you used that difference amplifier? Have you studied that? তোমাদের ইলেকট্রনিক সার্কিটের একটা ক্লাস হয়েছে না?
হ্যাঁ স্যার।
তাতে ডিফারেন্স অ্যাম্পলিফায়ার ছিল না?
হ্যাঁ স্যার, ডিফারেন্স অ্যাম্পলিফায়ার ওটাই ছিল না।
তোমাদের কি এই সেমিস্টার এখন ইলেকট্রনিক্স সার্কিটসের ক্লাস আছে? এই সেমিস্টার তোমাদের কি ক্লাস আছে আমারটা ছাড়া?
লিনিয়ার কন্ট্রোল সিস্টেম ক্লাস আছে, ডিএসএ আছে, ডিএসপি আছে, ইন্ডাস্ট্রিয়াল ইনস্ট্রুমেন্টেশন আর মেজারমেন্ট আছে।
তাহলে তো ইলেকট্রনিক সার্কিটসে তোমাদের তো ডিফারেন্স অ্যাম্পলিফায়ার তো সিলেবাসে ছিল নিশ্চয়ই, আমি তো রেখেছিলাম। হ্যাঁ বলো।
ডিফারেন্স অ্যাম্পলিফায়ারটা তো আপনার ওপিএমস এর যেটা চ্যাপ্টার ছিল সেটাতেই ছিল, তো সেই চ্যাপ্টারটা তো পড়ানো হয়নি আমাদেরকে।
না না না, অপারেশন অ্যাম্পলিফায়ার তো দ্যাটস এ ডিফারেন্ট থিং, কিন্তু ট্রানজিস্টর ইউজ করে ডিফারেন্স অ্যাম্পলিফায়ারের দেয়ার ওয়াজ ওয়ান পোর্শন ইউজিং বিজেটি। তোমাদের কে অভিজিৎ পড়েছেন না কে পড়েছেন? এসি স্যার পড়েছেন না কে পড়েছেন?
Easy, sir.
হ্যাঁ হ্যাঁ।
কিন্তু
ক্লাস আসলে একটুখানি এদিক ওদিক হয়েছিল ইলেকট্রনিক সার্কিটস এর, তো পুরো সিলেবাস কভারও হয়নি মনে হয়।
ও আচ্ছা, না সিলেবাসটা ছিল আর কি। এনিওয়ে, তাহলে ওটা তুমি তোমাদের পড়ে নিতে হবে, কেন কি দ্যাটস ওয়ান ইম্পর্টেন্ট পোর্শন, যেটা ইউজ করে গেটেও প্রশ্ন পাবে, এবং কম্পিউটার্সে যদি কেউ ইলেকট্রনিক্স লাইনে থাকতে চাও তাদের কিন্তু সেখানেও প্রশ্ন পাবে। তো ডিফারেন্স অ্যাম্পলিফায়ার ইজ ওয়ান ইম্পর্টেন্ট ওয়ান, ওই টপিকটা কিন্তু দেখে নিও একটু।
ঠিক আছে।
স্যার ওই ডিফারেন্স অ্যাম্পলিফায়ার ভায়া বিজেটি টপিকটা তো?
হ্যাঁ হ্যাঁ হ্যাঁ, ওই তোমার বেসিক সার্কিটে তোমার দেখিয়ে দিচ্ছে, এরা খানিকটা এরকম কাজ করতে হবে। সার্কিটে দেখতে ইট উইল লুক সামথিং লাইক দিস। এখানে একটা ইনপুট দেওয়া হয়, এখানে একটা আউটপুট, আর একটা ইনপুট দেওয়া হয়, এই দুটো আউটপুটের মাঝখানে আউটপুটটা নেওয়া হয়। তো যে কোনো ইলেকট্রনিক্স বইয়ে এই এই রিলেটেড সার্কিটটা স্টাডি করবে, দেখবে পেয়ে যাবে। দিস ইজ ওয়ান কারেন্ট সোর্স। এই কারেন্ট সোর্স, এক্স্যাক্টলি কারেন্ট সোর্স ইউজ না করো, অন্য এর ইন প্লেস অফ দিস সাম আদার সার্কিট মে বি অলসো ইউজড, but the basic module is this one.
ঠিক আছে।
These two matched BJT transistors will be there. Matched means their parameters are almost same. The alpha, beta, gamma, all those values are almost same. Ideally, it should be exactly same. I cannot ensure exact similar characteristics everywhere. So we should say that their characteristics should be almost same. So they are supposed to be matched transistors. So এই সার্কিটে কিন্তু পড়ে নেবে। তোমরা সিএমআর এর টার্মটা পেয়েছো? সেটা কোথাও স্টাডি করেছো? কমন মোড রিজেকশন রেশিও।
No, sir.
বাবা, তোমার একটু মুশকিল পড়ে যাবে তোমরা। এটা সিএমআর দিয়েও বেশ অঙ্ক আসে। এনিওয়ে, সো আমার এখানে যেটা লাগবে, দ্যাটস আই এম অ্যাজিউমিং by difference amplifier what we mean is there are two inputs, V1, V2. There is one single output. This output is proportional to the input difference. That is the basic operation of any difference amplifier. The output should be proportional to the input difference voltage. There will be two input signal sources. There will be only one output, and the output will be proportional to the difference between the two input voltages. Now there, if I have two voltages V1 and V2, they will be having one difference signal V2 minus V1. They might be having one common signal, that is the average of these two. So this VC is the common part of V1 and V2, and VD is the difference part of V1 and V2. Now, when you are amplifying, then the net output will be AC into VC plus AD into VD. Now, our aim of a difference amplifier is that the output should be exactly amplifying the difference signal, and it should not have any effect of the common part of the two input signals. So our interest is in this thing only. That means we expect that the AC value is
0.
Negligible.
and this AD is exactly your A. Okay, that should be the ideal scenario. But no difference amplifier is ideal. So there we go for one term, CMRR, common mode rejection ratio. Common mode rejection ratio means how well it is rejecting the common mode part of the two input signals at the output and only amplifying the difference mode part of the output. So this is by definition AD by AC. Ideally your AC should be
A.
0.
Ideally the AC should be 0.
0, 0.
Okay. Yes,
So ideally the CMRR value should be for a one difference amplifier.
A.
No.
Oh, sorry. Yeah. Acha,
yes. Infinity.
Yeah,
Okay.
infinity.
So CMRR for any difference amplifier should be ideally infinitely large. But that does not happen always. What we have is of the order of say 100 dB or 80 dB, something like this. The dB term, I think you know all.
Just
Yes, sir.
Okay, fine. Yeah, I think we should be able to convert one constant to dB and dB to constant also. That type of conversions are also quite requirement in many places. Anyway, so in any difference amplifier, we should try to ensure that the common mode part is not available at the output and only the difference mode part is available. So which parameter tries to ensure that the infinitely large CMRR ensures that the output of one difference amplifier is having only the difference part of the input and not any common part of the input effect and is available at the output. Okay, so for that we must ensure almost infinitely large CMRR, but infinitely large hote pare na, we try to go for around 80 to 120 dB CMRR. Now next is the operational amplifier.
স্যার
না বলো
স্যার একটা ডাউট ছিল এই ভিডি আর ভিসি
এটা লিখে নিয়ে তারপর বলবো।
এস
হ্যাঁ বলো
স্যার এই ভিডি আর ভিসি ওই পার্টটা আরেকবার বলতে পারবেন মানে ওটা ওটা কি ডিফারেন্স অ্যাম্পলিফায়ারের ক্যারেক্টারিস্টিক্স টাইপের
না না এটা যে কোনো সিগন্যাল যে কোনো দুটো সিগন্যাল যদি নাও
ইয়েস স্যার
ভিএ নিয়েছে একটা ভিবি নিয়েছে I do not know where from I am getting those. So, but it may so happen that these two signals are having some common part. How will you find out the common part? Common part is nothing but the average.
Average. Yes,
if you add these two, in that case, the common part is getting added twice, and the difference part is getting subtracted. So if I go for V1 plus V2, the common part what was available in both VA and VB are now having 2 times. So let me divide that by 2. So VC, the common part between VA and VB is half of VA plus VB. এখানে যেটা আমরা V1 V2 নিয়েছি।
Yes, sir.
And the difference part টা কি হবে? আমি VA minus VB যদি করি কমন পার্টটা সাবট্রাক্টেড হয়ে গেল।
Yes, sir.
And only the difference part is available.
Okay.
So that's why VD is equal to V2 minus V1 by VA minus VB.
Yes, sir.
Okay.
Yes, sir.
Fine. Now operational amplifier. Now, operation amplifier is nothing but one special type of difference amplifier. So this is basically one difference amplifier with certain special characteristics. সেই special characteristics গুলো কি কি, we will come to that later. But as it is one difference amplifier, how many inputs, the primary input should be there?
2.
2. How many outputs should be there?
1.
1. So basically this is one 3-terminal device. Apart from these 3 input outputs, some other DC source inputs should also be available.
Yes, sir.
Kota?
দুটো।
One is plus Vset, the other one is minus Vset. The gain of this difference amplifier is termed as AOL. AOL stands for open loop gain. There is no feedback from output to input side. I have not connected anything here. So this circuit is operating in open loop mode. So that open loop gain of the operation amplifier is being termed as AOL. যদি closed loop gain হতো আমি সেটা বলতাম ACL. For the closed loop gain I would have termed it that as ACL. One is open loop gain, the other one is the closed loop gain. Fine. Now let these two term input voltages be termed as V1 and V2, and let the output be V0. So as per the fundamental principle of one difference amplifier, assuming infinite CMRR, what will be the expression of V0?
AOL V2 minus V1.
AOL into VD, where VD is the difference, input difference voltage. Now here the input difference voltage VD is by definition, it is V2 minus V1. This is by definition. Okay, fine. So that means this is nothing but AOL into V2 minus V1. Fine. Now, if I ground it and if I connect here V in, so what will be your expression for V0?
Minus AOL V1.
AOL into V.
Minus AOL into, sorry, V in. Okay. I have applied V into that V1 terminal and ground to the V2 terminal. So the expression of the output will be minus of AOL into V in. Now, what is the phase relationship between V in and V0?
180 degrees.
So that means V0 is out of phase, 180 degree out of phase with the given input signal. This is one observation. Second thing, let me connect ground terminal, ground voltage to V1 terminal and V in to V2 terminal. So what will be your output?
AOL into V in.
So what is the phase relationship between now V in and V0?
In
Same
phase.
phase.
They are in phase. So what I find is if the input is given to the V1 input terminal, it is getting inverted at the output, having 180 phase shift. So I can say that when it is available at the output, it is getting inverted. Whereas if the input is getting connected to the V2 terminal, it is not getting inverted. So now onwards, these two terminals, this is minus, this is plus, these two terminals are called no longer, we shall never term them as minus terminal, plus terminal. We shall always term them as this as the inverting input terminal, and this as the non-inverting input terminal. So the op-amp, there will be three primary terminals. One is the inverting input terminal, the other one is the non-inverting input terminal, and the third one is the output terminal. Apart from these three, there must be some plus minus VSAT inputs. Okay. So a basic Pachkhana, these five terminals, regarding the basic five terminals, I think the idea is clear.
স্যার মাইনাস প্লাসটা কি এই গেইনটার জন্য সরি মানে V0 এর জন্য বলা হচ্ছে
basically that is getting introduced due to this concept. The input difference voltage is V2 minus V1.
Yes, sir.
That is possible only if V2 is being termed as the one terminal, which is symbolically represented as plus terminal, and the V1 is basically given to another terminal, which is symbolically given as the minus terminal. And my difference voltage is always whatever the input voltage is connected to the plus terminal minus the whatever input voltage that is connected to the minus terminal. Okay?
Yes, yes, sir.
Is there still some doubt?
স্যার মানে ওইটা কেন দিচ্ছি মানে
No,
এটা কি কোনো ফর্মাল
these two terminals are basically symbolically I am representing. Now, a terminal whatever voltage I am connecting, and a terminal whatever voltage I am connecting, I am subtracting this voltage from this voltage.
Yes, sir. Yes.
Had I subtracted this terminal voltage from this terminal voltage, in that case my plus terminal would have been that, and my minus terminal would have been like this.
Okay, okay.
In the circuit symbol, I must distinguish between these two terminals. As VD, which signal voltage minus which signal voltage I am expecting. That I must represent symbolically also. So that's why that plus symbol and minus symbols are there. Because my VD, different input difference voltage, remember this VD is always called the input difference voltage. This input difference voltage will be always plus input terminal voltage minus input terminal voltage. Okay, as there are two input terminals, as the input difference voltage, I must subtract one input voltage from the other input voltage. Now the input voltage which I am subtracting, that terminal is symbolically represented as the minus input terminal, and from where I am subtracting, that input terminal is being represented by the plus input terminal. That's all, nothing else.
Yes, sir. Okay, sir.
Fine. Now the characteristics of one op-amp. First of all, open loop gain. Ideally, that should be infinitely large. Practically, that should be of the order of 10 to the power 5 to 10 to the power 6. Pretty large. Ideally, for one operation amplifier, the open loop gain must be infinitely large, whereas practically that infinite large gain is not possible. We can reach at 10 to the 5 to 10 to the 6 practical gain of AOL. Next is input impedance. Ideally, what should be the input impedance value?
So infinite.
Infinite.
Why? Why infinite?
So
That
that
also I think কিসের জন্য?
so that
Loading
is
effect.
current.
Yeah, to avoid loading effect.
Loading effect.
This is of the order of several megohm. Output impedance, ideally
0.
zero. Practically of the order of tens of ohms. Then becomes bandwidth. Bandwidth, what do you mean by bandwidth? Is the frequency range over which the output signal nature truly follows the input signal nature. The output signal nature will truly follow the input signal nature throughout this input signal frequency range. এবার আউটপুটে ইনপুটে একটা সাইন ওয়েভ দিয়েছি, আউটপুটে আমি সাইন ওয়েভ না পেয়ে অন্য কিছু পাচ্ছি। That means for that frequency, the output signal is not following the input signal nature. Nature means waveform nature. Only the magnitude may be different. Okay. So ideally, the bandwidth of one operation amplifier should be
Infinite.
infinite. Whatever may be the input signal frequency, the output should follow the input signal nature. But practically, that does not happen, of the order of several megahertz. Then comes slew rate. Now, what do you mean by slew rate? Say, if I have one amplifier, forget about the difference amplifier. Forget about difference amplifier, forget about operation amplifier. I have one general amplifier. If the input is one square wave, the output is expected to be
Another square wave.
only. The square wave only the amplitude may be a different one. Doesn't matter. Let us sketch the output. This is say -1 volt. Here this +2 volt. Okay. Now, at this time instant, what is the rate of change at the output?
Infinite.
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 At this instant,
Minus
Minus
infinite.
infinite.
so truly speaking, at the edges of the square wave pattern, I expect the the amplifier output to be changing its state at a rate plus infinite or minus infinite. The same is true for the operation amplifier also. But every practical amplifier has got a certain limitation. It is every amplifier or every operation amplifier will be having certain finite slew rate. What do I mean by a slew rate? Slew rate is the maximum allowed dV0 dt. This is the maximum rate of change that is possible at the amplifier output or at any electrical node. This output is also one electrical node. So at any electrical node, there might be a certain maximum limit at which the output can have its state change. So the dV0 dt max is the slew rate of that particular device. Same is true for the operation amplifier also. In the case of operation amplifier also, the output will be having some finite slew rate. Now, what is the order of the slew rate? Himanshu Ranjan, what is the time now?
Sir, I am very sorry, sir. Just by mistake, sir, I missed out.
Okay, no problem, no problem, no problem. This slew rate, what is the normal order of the slew rate? For the operation amplifier, it is of the order of several volts per microsecond. So if it is say 2 volt per microsecond, that means the maximum rate at which that particular operation amplifier output can have a state change is 2 volt in every 1 microsecond. But if the required waveform is something like this, can you achieve this particular response at the operation amplifier output where the slew rate is 2 volt per microsecond?
No, sir.
So what actually you'll be having is the response will be something like this. You'll start moving like this, then once again it will start drooping like this. So this rate will be 2 volt per microsecond, and this here it will minus 2 volt per microsecond. This slope and this slope. Okay, they cannot have infinite, plus infinite and minus infinite slope. That will be, this slope will be governed by the slew rate of that particular device. Okay. So in the case of operation amplifier, what should be the value of the slew rate ideally?
Infinite.
Infinity.
Several of the order of several volt per microsecond. Fine. Next is reduce it. Input offset voltage, VIO. Now, what do we mean by input offset voltage? What is the expected output here?
Sir, 0.
0. Why? Now,
So
what is the
then-
input device voltage here?
Both 0.
VD is 0. So
Yes.
my output should also be 0. Ideally. That should happen ideally. But what happens is, even if you connect the 2 input terminals and short the 2 input terminals and connect that common point to ground, the output you may not found to be 0 practically. You may find that the output voltage is say plus 1 volt, maybe minus 2 volt, maybe plus 15 volt, maybe minus 6 volt. The output voltage may be any value. Now, had it been one ideal operation amplifier, there is no chance that the output will be anything other than 0. But as it is not one ideal operation amplifier, as it is one practical operation amplifier, and this in practical operation amplifier, even if we short the 2 input terminals and even if we connect that common point to ground, the output in almost 99.99% cases won't be 0, something other than 0. So let the output voltage is some V0. Let me make it capital V0 to distinguish between the common V0 signals and this particular available V0 signal. Now, the open loop gain of the op amp is AOL. Now, if I have to give some reason behind this available non-zero V0 at the output. I have no other option but to say that my two input terminals are not exactly the same potential.
Yes, sir.
And what is the input difference voltage? Now, that input difference voltage, the actual input difference voltage or the practical input difference voltage in this case is nothing but
V0 by AOL.
okay. So that means from some source, as if I am getting this input difference voltage, though I have not connected that physically. Physically, the two input terminals are in the same level. Physically, the input difference voltage between the two input terminals is physically how much?
V0 by AOL.
Zero. No.
Zero.
Physically, by connection, how much input difference voltage you have applied?
Oh, okay, 0.
Zero. That is the input difference voltage that we have applied is 0. But as at the output I am getting some non-zero output voltage, so that available non-zero output voltage at the output is forcing me to visualize that there must be somewhere some input difference voltage available. I do not know where. I don't know where. But there must be some input difference voltage Vd is equal to V0 by AOL somewhere internal to the circuit, which is not external to the circuit. Externally, I am having absolutely zero input difference voltage by connection. But to establish some physical meaning of that non-zero output voltage, I am forced to think of one DC source of voltage having the magnitude this internal to the circuit. So this is my practical operation amplifier configuration. And as if assuming that this internal to this practical operation amplifier, where the inverting and non-inverting input terminals are already shorted and grounded. Internal to this practical operation amplifier, I have one ideal operation amplifier. Ideal means for this ideal operation amplifier, if the two input terminals are in the same potential, the output is guaranteed to be 0. In the case of one ideal operation amplifier, if the two input terminals are at the same potential level, the output is guaranteed to be 0. But this is not the case here. Here, this is one practical operation amplifier. Though the input terminals are shorted and grounded to 0, the output is coming as certain non-zero value. So that's one practical operation amplifier. So inside the practical operation amplifier, we are assuming, I am forcing on this term assuming. So internal to the practical operation amplifier, as if there is one ideal operation amplifier and one DC voltage source. This DC voltage source is called the input offset voltage VIO. Now, what is the value of this VIO? This is the VIO. V0 by AOL. This is your AOL. Okay. Now, for this ideal operation amplifier, what is the input difference voltage?
0.
No, for this ideal operation amplifier.
Oh, VIO.
Minus VIO.
Minus VIO or VIO?
+2. Okay, sir. Yes, sir. VIO.
Just VIO.
Okay, so that is VIO. So if you amplify that VIO by AOL, you'll be getting that V naught value. Is it not?
Yes, sir. Yes, sir.
Yes, sir.
So to have some mathematical reasoning for the available non-zero output voltage for the practical operation amplifier, where the two input terminals are having the same potential level and that to zero, we are going for one modified model where internal to the practical operation amplifier, I am having one ideal operation amplifier along with one fictitious voltage source VIO. Remember, there is no physical presence of this VIO. Only for the mathematical, to give one mathematical reasoning for the non-zero output voltage at the practical operation amplifier output, we are assuming the presence of this VIO and that ideal operation amplifier. There is nothing like ideal operation amplifier. There is nothing like one DC source VIO in physical mode. In physically, what I have is one practical operation amplifier which I have fabricated in the foundry. So in the foundry, I can never fabricate one ideal operation amplifier along with one DC source, and then I'll package that as one practical operation amplifier. That is never possible. What is possible from the foundry, that we can design one practical operation amplifier. But to give some mathematical reasoning for the available non-zero output voltage in this particular case, where the two input voltages are in the same potential level, that took zero, we are visualizing the practical operation amplifier as a combination of one ideal operation amplifier and one fictitious voltage source VIO. This VIO, remember, this VIO has got no physical presence. This one voltage source we just assumed to be present. Physically, this is never available. This is never present. Its presence is only assumed. To give one mathematical relationship to find out the to give some reasoning behind that non-zero output voltage at the case where the two input voltage are at the zero level. That is, the VD is zero level. So in our characteristics of the operation amplifier, this input offset voltage VIO, its value should be ideally zero, practically of the order of millivolt. Next is
sir. স্যার বলছি মানে এই লাস্টের যে কেসটা হলো স্যার, ওখানে কি মানে অ্যাকচুয়ালি ওটা হচ্ছে কারণ ওই দুটো ব্রাঞ্চের মধ্যে রেজিস্ট্যান্সটা ডিফারেন্ট, ওয়্যারের যে ব্রাঞ্চিংটা করছি, মানে অ্যাকচুয়ালি কেন হচ্ছে?
না ও তার কোনো সম্পর্ক নেই।
ও আচ্ছা আচ্ছা,
এখানে কোনো দুটো ওয়্যারের মধ্যে কোনো রেজিস্ট্যান্স বলে কিছু থাকে না।
স্যার ধরুন প্র্যাকটিক্যালি আমরা একটা ওপেন নিয়ে কাজ করছি।
হ্যাঁ বলো।
তো ধরুন আমরা প্র্যাকটিক্যালি একটা ওপেন নিয়ে কাজ করছি, তখন মানে আমাদের তো এই অফসেট ভোল্টেজটা দেখাবেই, হ্যাঁ। তো মানে তখন কি আমরা ভ্যালু ক্যালকুলেশনের সময় মানে যদি কোনো একটা কিছু করি তো ওটা মাইনাস করে দিতে হয়?
শুনো, মানে না, এবার আমি বলি, দিস ইনপুট অফসেট ভোল্টেজের ম্যাগনিটিউড যেটা, দ্যাট ইজ অফ দি অর্ডার অফ মিলিভোল্ট।
আচ্ছা হ্যাঁ, তাহলে তো অত বেশি
1 millivolt বা 2 millivolt. So if my actual signal that I am using is of the order of several volts, in that case, with respect to that, I can most of the time I can ignore that. But there is a big but. If my application is in the small signal domain, That means my actual signal is of the order of 100 millivolt or 50 millivolt. There definitely we should take care of this input offset voltage.
Okay, sir.
Okay, but not always.
Okay,
কি করে টেক কেয়ার করতে হয় না সেগুলো পরে দেখবো আমরা।
ঠিক আছে
স্যার এই ভোল্টেজটা সোর্স কি স্যার?
There is a সেটা আসবো পরে আসবো। Remember, this is not any voltage. This is not any physical voltage. Just give one mathematical relationship between the input and the output. We are assuming the presence of this voltage source. There is no physical voltage like this VIO. তুমি অপন যদি খোলো বা কিছু করে তুমি ভিতরে কোথাও এই VIO বলে ভোল্টেজ সোর্স খুঁজে পাবে না। জাস্ট একটা ম্যাথমেটিক্যাল রিলেশনশিপ ইনপুট এবং আউটপুটের মধ্যে ভ্যালিড ম্যাথমেটিক্যাল রিলেশনশিপ রাখতে গিয়ে আমাকে দেখলাম যে জিরো ইনপুট ভোল্টেজ ডিফারেন্স ভোল্টেজ দিলেও আউটপুটে নন জিরো পাচ্ছি, তার মানে আমার ম্যাথমেটিক্যাল যে রিলেশনশিপটা সেখানে নতুন কিছু টার্ম ঢোকাতে হবে। So that to introduce that term, we are assuming the presence of this VIO. Remember, this is one purely fictitious voltage source. This is not any real voltage source. এবার কেন আউটপুটটা নন জিরো হয়, ইনপুট ডিফারেন্স ভোল্টেজ জিরো থাকলেও পরে আসছি তাদের, আজকেই আসবো হয়তো একটু পরের দিকে। Finally, another term, input bias current or input offset current. Ideally, একটা অপারেশন অ্যাম্পলিফায়ার ইনপুট ইম্পিডেন্স কত? What is the input impedance of one ideal operation amplifier?
Infinite.
The input bias current means, acha, this is the basic difference amplifier module. So though my operation amplifier is called one operation amplifier, this is basically one special type of difference amplifier, nothing other than that. So if it has to be one different type of difference amplifier, it must be having some circuit like this inside it. This is the fundamental nature of one difference amplifier. Now here what we find, there are two active components, two BJTs. So for any BJT to operate properly, they must be biased properly. Is it not?
Yes, sir.
For any transistor to operate properly, transistor means I am not talking about the unipolar transistor, I am talking about the bipolar transistor. For any BJT to operate properly, it must be properly biased. So I must have some input bias current here and input bias current here, IB1, IB2. Now here I am giving as if V1 input, I am giving V2 input. In the case of operation amplifier, the V2 input is given to the non-inverting input terminal and V1 input is given to the inverting input terminal. So similarly, so this must be termed as the IB minus and this is termed as the IB plus. The input bias current that is entering into the difference amplifier through the minus input terminal, that means the inverting input terminal, and through the non-inverting input terminal respectively, IB minus and IB plus. They are the which I earlier wrote as IB1 and IB2. So now onwards, I'll be terming them as IB minus and IB plus. IB minus is the input bias current that is entering through the inverting input terminal, and the IB plus is the input bias current that is entering through the non-inverting input terminal. Fine. So that means there is something like IB minus entering in through this inverting input terminal and some input bias current that is entering through the non-inverting input terminal. Now, between this inverting and non-inverting input terminal, I have the input impedance. Is it not? Between these two terminals, I have the input impedance. Now, what is the value of this input impedance ideally?
Infinite.
Infinite. So, what should be the ideal values of IB minus and IB plus?
0.
0. But remember, for these difference amplifier to operate properly, this IB minus IB plus cannot be practically 0. If they are practically 0, in that case, they are not properly biased at all. So they must be having some finite bias current. So though ideally the bias currents are 0, practically of the order of microampere. Now, we are defining two terms. One is the input bias current, IB. What is IB? Now, IB is the average of these two. And another term we are defining, input offset current. That is the magnitude of the difference. Now, in case of the ideal situation where the IB minus and IB plus are both exactly same, in that case, IB will be equal to your IB plus and also equal to IB minus. And what will be the value of IOS there? In the ideal situation, when okay, that means ideally iOS should be 0, and IB should be observed something of the order of microampere. Now, typically, it has been found that in all practical scenarios, this iOS remains less than 25% of IB in most of the situations. That means if you go for any data sheet of an operation amplifier, you will find that iOS value is found to be typically less than 25% of the typical values of IB. So that's the difference between the input bias current and the input offset current. By definition, input offset current is the difference between IB plus and IB minus, and input bias current is by definition the average of IB plus and IB minus. Okay, fine. These are the basic characteristics of the operation amplifier. But the main characteristics which will be interested here, or mostly you will also be interested in future also, these how many? 7 or 8? 7. These 7 parameters. By the way, I have not given the justification for assigning the name operation amplifier to this special type of difference amplifier. Using this difference amplifier, this special type of difference amplifier, which we are going to study in details, we can perform many special operations, both mathematical as well as logical. That's why this particular difference amplifier is given a special name, operational amplifier. This difference amplifier helps us in realizing various types of both mathematical and logical operations. So that's why it is given a name, operational amplifier, because so many operations, both mathematical and logical, can be performed using this particular circuit element. Now we are going to study the basic building blocks of the operation amplifier. Remember, in one operation amplifier, there will be around 57 or so number of transistors. So this is really very difficult to understand or analyze that particular internal circuitry of operation amplifier. I cannot understand, and I do not dare to make you understand also that. So basically, we will be confining ourselves to the basic building blocks of the operation amplifier. So though we are saying that they are the basic building blocks, but in many cases, even two blocks may be interconnected also. But we are trying to broadly distinguish between the two every building blocks as per their operational requirements. Now, what is one operation amplifier? This is nothing but one basic difference amplifier or the special type of difference amplifier. So using the operation amplifier, we must be able to realize the function of one difference amplifier. So the very first stage of the operation amplifier should be one difference amplifier, where two inputs will be there and one output will be there. Now, what should be the characteristics of the operation amplifier that should be achieved through the difference amplifier? As this is the very first stage, kon characteristics of the op-amp should be realized by this particular first stage?
Infinite, almost infinite CMR. Infinite CMR.
Infinite CMR, because it is the difference amplifier which is converting two input terminals to one output terminal. That means this difference amplifier is basically ensuring that only the difference mode part is getting converted to the output, and the common mode part is getting rejected. So the infinite CMR should be one of the characteristics of this difference amplifier of the first stage. What else?
Infinite impedance.
Infinite which impedance? Infinite which impedance?
Input
impedance. The infinite input impedance. So infinite input impedance and the large CMR or infinite CMR, they should be the objective of this difference amplifier. Now, while ensuring this, it cannot ensure infinite gain. To ensure infinite CMR and the infinite input impedance, what will be constant with is it cannot ensure infinite gain. So to introduce infinite gain, after this, we have one gain stage, or a high gain stage. There is one gain stage or high gain stage, whatever you say. So the purpose of this gain stage to ensure infinite AOL, infinite open loop gain. Now, while ensuring the infinite CMR, infinite input impedance, and the infinite gain by the combination of these two stages, what we cannot ensure is that the operating point should be at the 0 point. in the transistor, the common emitter transistor amplifier, there is something called operating point. You know that?
Yes.
Yes, sir. The Q.
What is the significance of that?
But about which the point of biasing.
What is the significance of that? If the input voltage is 0, then what is the output voltage?
0.
No. The output voltage will be corresponding with that particular operating point. If for the input voltage, the output voltage is 0, in that case, the operating point will lie here. Here. If the input, by input voltage, I am talking about the input AC voltage. By biasing, what you do? You give one DC shift to that input AC.
Yes, sir.
Yes, sir.
Isn't it? So, if the applied input voltage is 0, in that case, the output will be corresponding to that particular input bias voltage. So, at the operating point, what output, what voltage you are having, that voltage will be available at the output. Why that operating point is required to be set at the near midpoint?
So for maximum symmetrical swing.
Yeah, you have maximum symmetrical swing at the both plus and minus end. But do you actually get a negative voltage there at the output?
No, sir.
No, sir.
Because of your applied DC voltage in the common amplifier are plus 5 volt, that or the whatever it is, plus VCC, and what is the minus saturation voltage in the common emitter amplifier? What are the two DC sources? One is the plus VCC.
Ground.
What is the other
one is ground.
It's the ground. So that means the output voltage will swing between 0 and that VCC. So if you place the operating point at 0, in that case, no output, no negative swing will be available. Only the positive half cycle of the input AC waveform of the output AC waveform will be available. No negative half cycle will be available because my operating point itself is the ground point, and my output cannot go beyond 0. So if you place the operating point somewhere here, say at 2 volt, in that case 2 volt to 0, this part of negative swing that is allowed at the output. Okay, so similarly here also in this combination of difference amplifier and the gain stage, to have proper swing available at the output, we must have placed the operating point at some non-zero DC voltage. Is it not? Just like your common emitter amplifier, same concept. So to have proper swing at the output, this difference amplifier and the gain stage combination must have the operating point set at non-zero voltage. So what does it ensure? It ensures that even if the input difference voltage VD is 0, the output of this gain stage, will it be 0? If the VD is 0,
no, sir. Some non-zero value. So the Q point.
At the Q point, at the operating point. Okay, but what is your requirement? What
so
is
we
your
need 0.
The output should be 0. So for that, what it requires is one level shifter. I require one level shifter stage. What is the function of this? It tries to ensure 0 output when the input difference voltage is 0. So that means when the input difference voltage is 0, the gain stage output is having that DC offset. So this level shifter is bringing the DC offset to 0 level. Okay, so it is a function of this level shifter which tries to ensure 0 output for 0 input difference voltage by design. Because when you are designing the circuit, you are assuming certain internal parameters of the circuit components. With those internal parameters considerations, with the resistance values, with the DC supplies, you have arrived at the operating point for this combination of the difference amplifier and gain stage. You're trying to bring that operating point to 0 by this level shifter. Okay, fine. Everything is in paper design. Fine. So far so good. That means here I have my difference amplifier is ensuring infinite CMRR, infinite input impedance. High gain stage is trying to ensure infinite AOL. Level shifter is trying to ensure 0. What level shifter is trying to ensure which parameter to become 0?
So V0 at VD0. So V0 0 output.
No, this level shifter is trying to ensure that my VIO is 0. Input offset voltage is 0, isn't it?
Yes, sir.
Yes, sir.
Basically, yeah, you are also right. You are also right. This level shifter is trying to ensure V output is equal to 0 for VD is equal to 0. You are absolutely right. But regarding my operational amplifier characteristics, which parameter it is trying to ensure 0? It is nothing but the VIO, input offset voltage. It is trying to ensure 0. Is it not?
Yes, sir.
If the output becomes 0 for VD is equal to 0, in that case, what will be the value of VIO?
0.
So basically, this level shifter is trying to ensure 0 output for 0 input difference voltage, or you can also say that it is trying to ensure 0 input offset voltage. Now, out of the major characteristics, which characteristic is still left?
Output impedance to be 0.
Output impedance to be 0. Now, which type of amplifier introduces almost 0 or very small output impedance? Common collector, or the emitter follower, or one that is also called a buffer. So this CC amplifier tries to ensure almost 0 output impedance. So these are the 4 basic building blocks of the operation amplifier. Now, can you tell me why the operation amplifier is not producing 0 output for the 0 input difference voltage in the practical field? Where can it go wrong?
Ideal value to পাচ্ছে না প্রথম
দুটো blocks.
Had it been ideal, there is no question of getting non-zero output voltage for the 0 input difference voltage. But if I go for while discussing the 4 basic building blocks of the operation amplifier, have I ever talked about any DC voltage source, hypothetical voltage source, or fixed voltage source inside this to be present inside this operation amplifier blocks?
No, sir.
But what we are having is practically this operation amplifier may not produce 0 output for the 0 input difference voltage. Where can it go wrong? Can it be due to the difference amplifier stage?
Sir, CMRR will not
amplifier?
the CMRR will not be infinite.
No, in case my output is non-zero, that does not mean my CMRR problem is there.
Yes, sir.
My problem is here that the output is becoming non-zero even if the input difference voltage is zero. So which part of these four basic building blocks might have gone wrong?
So level shifter.
Level shifter.
That's the level shifter. It was the purpose of the level shifter to ensure zero output for the zero input difference voltage. Is it not? But that is not happening. That is not happening. Why it is not happening? It is not happening because the level shifter was designed with certain assumption of parameter values for the difference amplifier stage, gain stage, level shifter stage, all these stages. All the components that were used that would be fabricated, it was assuming certain parameter values. But let us assume that while fabricating, those parameter values were exactly the same. But remember, these parameter values change with environmental conditions. The transistor alpha value, beta value, transistor resistance, junction capacitance, everything gets changed with the environmental changing environmental condition. Is it not? I think you have to read all those things. So the level shifter assumed certain parameter values. But while working in the actual field, it is finding that those parameter values are not the same. So what it can do? It can do nothing. It can do nothing. It tries to function with those designed parameters, but as those parameters are not the same, are no longer those at the same level of the designed parameter levels, so the level shifter is not able to give the proper functionality. So the level shifter cannot help it because it has already been designed and fabricated. So in the practical while the op-amp is being applied practically, this constant of the level shifter is being reflected at non-zero output voltage for the zero input difference voltage. But here you cannot help it. You cannot say that internal to this operation amplifier there is some voltage source. You cannot say that. The non-zero output is becoming available only due to the improper functioning of the level shifter. And that is also not a fault of the level shifter. It is happening due to the changes that have happened to the assumed parameter levels in the practical field. So to account for this non-zero output voltage, we have no other way but to go for one assumption of one practical operation amplifier to be consisting of one ideal operation amplifier and one fixed pieces voltage source, which is being termed as the input offset voltage. Is this point clear?
So একবার repeat করুন।
We have seen that this VIO was there. That means one practical operation amplifier that is producing non-zero output voltage V0, even if the two input terminals are shorted. That means the VD is zero. Even if VD is zero, I am having non-zero output voltage. Now, who is it is the function of which circuit block here to ensure zero output voltage for the input difference voltage zero? It was the function of the level shifter. But in the practical application or in the practical field, the level shifter is unable to give that performance. Why? That also we have explained. In that explanation, is anything else required? Do I have to repeat that?
No, sir.
Fine. So now it is pretty clear that when we are using the operation amplifier in the practical field, the level shifter cannot give the proper functionality. So the output is becoming non-zero, even if the VD is 0. That means this is the situation. This is the situation. But mathematically, what I have V naught is equal to AOL into VD. That is the relationship I have. But here, if I have to explain this relationship, this nature of the output response, I have to introduce some mathematical relationship between the input and the output.
Yes, sir.
So to do that, we have no other way but to take help of the assumption. I'm enforcing on the term assumption. Assumption that this practical operation amplifier is having as if two components. One is one ideal operation amplifier, whose output is this output, whose inverting input terminal is this practical operation amplifier inverting input terminal, and whose non-inverting terminal between the non-inverting input terminal of this ideal operation amplifier and the non-inverting input terminal of the practical operation amplifier, I have one fictitious voltage source. And this voltage source is called the VIO value. If I can assume it, I can explain the input-output relationship of this practical operation amplifier also. So to have one mathematical explanation of the input-output relationship of this practical operation amplifier, we have to consider that the practical operation amplifier is consisting of two components. One is the ideal operation amplifier and one fictitious voltage source VIO. This value of the VIO may change. This polarity of the VIO also may change, because this V naught value at a certain point of time may be plus 0.5 volt. After 1 hour, that may be minus 2.3 volt. It totally depends on the internal parameter values. So parameter value gulo je change kore, level shifter functionality also that will also change. The improper functioning of the level shifter, that level also change. So might be for a set of particular parameter values, the output voltage was found to be 0.5 volt. After 2 hours, after 3 hours, or after 1 day, I may find that the output voltage is becoming 2.3 volt, minus 2.3, minus 6 volt, minus 7 volt, whatever it may be. So it is not guaranteed that the output voltage will be a fixed value. So output voltage with parameter changes will go on changing. So as a result, we cannot assume the VIO level to be also fixed level. So mathematically, that VIO should be one changing value, magnitude-wise, as well as phase-wise, sign-wise. So it may be positive, it may be negative, it may be ranging from any value to any value. So VIO is basically one variable voltage. So fictitious. Remember, this once again I am enforcing on the term that this is one fictitious voltage source, VIO. So the presence of VIO is basically have to be assumed due to the improper functionality of the level shifter stage of the operation amplifier. Anything else I need to say?
No, sir.
Fine.
স্যার অনেক সময় মাল্টিমিটারের দুটো টার্মিনালকে একসাথে যখন যদি আমরা টাচ করাই তখনও স্যার কিছু একটা রিডিং দেখায়।
না, মাল্টিমিটারটা অন্য কনসেপ্ট, দ্যাট ইজ নট ওয়ান ডিফারেন্স ওয়ান অপারেশন অ্যাম্পলিফায়ার। সেটা হচ্ছে তো মাল্টিমিটারে তোমার সেটা তুমি ভোল্ট মোডে দেখছো না রেজিস্ট্যান্স মোডে দেখছো, তার উপর ডিপেন্ড করবে। কারেন্ট মোডে থাকলেও আরেক জিনিস হবে। তো মাল্টিমিটারের সঙ্গে গুলি ফেলো না, দ্যাটস এ ডিফারেন্ট ইস্যু।
Sir, Sir, so can we say that under similar conditions the VIO should be constant?
But that similar condition will never happen.
Yeah, sir. Ideally.
Ideally, if the two conditions are same, VIO should also be same.
Okay, sir.
That will definitely be true.
Sir, so VIO is completely fictitious. Like we don't know where it's exactly coming from.
Yeah. Okay, it's completely. This is completely hypothetical.
Okay, sir.
There's no physical presence of that.
So, isn't there a way by which we can explain it?
But that for that explanation, I'm saying, this level shift is not functioning properly. So as a result, the output voltage, I am getting some non-zero output voltage, but my relationship between the input and output is governed by this. So this cannot explain the non-zero output voltage for the zero VD. So that can be explained only if I can assume the internal to the practical operation amplifier, I have two components. One is the fictitious ideal operation amplifier and one fictitious input voltage, fictitious DC voltage source VIO. That's all.
Okay, sir.
We're going to draw the transfer characteristics here. What will be the expression for V naught? What will be the expression?
VI.
10 to the power of 5
VI.
to VI. The VD is equal to VI minus 0, that is VI. Okay. V naught is equal to AOL into VD. The value of AOL is equal to 10 to the power 5. So V naught is equal to 10 to the power 5 into VI. Fine. What are the two saturation voltage levels?
So plus 10 volt, minus 10 volt.
Fine. So that means to plot the transfer characteristic, let me first find that range, mark that range. At which input voltage the output will reach plus 10 volt?
10 to the power minus 4.
10 to the power minus 4.
So that means minus 0.1 millivolt. No, plus 0.1 millivolt.
Yes, sir.
Yes, sir.
So and when will it reach minus 10 volt? Similarly, minus 0.1 millivolt. Okay. So there, what is the input voltage range where the op amp is operating in the linear region?
So minus 0.1 millivolt to 0.1 millivolt.
That is nothing but plus minus. But while I am using any circuit in one practical field, the available noise level in any practical field is of the order of several millivolt. So out of that several millivolt, this plus minus 0.1 millivolt is too small. Is it not? My noise voltage level itself is more than 1 millivolt in most of the situations. So what I find is the linear operating range of this operation amplifier is too small. It is that means it is practically not applicable or usable as one amplifier. What? As the available input voltage range where the op amp is operating in the linear region is too small, so what I can say is this operation amplifier is hardly ever, this operation amplifier can hardly ever be used as one amplifier. For an operation amplifier to be used one amplifier, for any device to be used as an amplifier, it must operate in which range? Linear range or non-linear range? Linear region or non-linear region?
Linear range.
It must be used in the linear region. Now, for this operation amplifier, if it is to be used in the as one amplifier, it must be used in the must be usable in the linear region. Now, that linear region itself is too small, plus minus 0.1 millivolt. My noise voltage level is much higher than that range. So, this operation amplifier, as such, the operation amplifier, I repeat, the operation amplifier as such cannot be used as one amplifier. If I try to plot this transfer factor in true scale, if I say that this is my plus 10 volt, this is my minus 10 volt, if I plot the x-axis also in the same scale, where that 0.1 millivolt and minus 0.1 millivolt will lie?
So nearly y-axis.
The origin itself.
Yes, sir.
So my characteristics will now look like something like this. Is it not? If I plot the x-axis and y-axis in the same scale, only if I expand this region, then I'll find this type of characteristics. Is it not?
Yes, sir.
So, practically, what characteristics I am getting? Now, this is the transfer characteristics I am getting. So, there what you find is absolutely almost there is no usable linear region at all. So, as there is no usable region, so this device cannot be used as an amplifier as such. But can it, in that case, if this cannot be used as an amplifier, then what is the use of this particular device? Now, from these characteristics, what we find? This is your VD or VI, whatever you say. In this case, VD and VI both are same. Is it not? In this case, by VD and VI both are same. Here?
Yes, sir.
Okay. So V0 versus VD or V0 versus VI, if I plot it, it will be something like this. Now, even you can forget about the VI. You may say this is VI2 and this is VI1. So what will be your VD?
VI2 minus VI1.
VI2 minus VI1.
Okay. So in that case, this characteristics will be same if I replace this VI by VD. Is it not?
Yes, sir.
Because my V0 is nothing but this. So that is reflected here. Okay. Any doubt?
No, sir.
No, sir.
Now, practically, if I do not expand the region near the origin, this transfer characteristic will be nothing but this. Now, what is the use of this particular transfer characteristic? What is meant by you? What do you understand by this particular transfer characteristic? But rather, what do you infer from this transfer characteristic? Where this is your input difference voltage. What can you infer from this transfer characteristic? What do you infer from this?
So we can qualitatively determine which input is bigger, like greater in magnitude.
No. From this transfer, what do you can infer that you have to tell me?
So it will have only two distinct outputs.
Fine. Next.
So the transistor will always work on saturation region.
Who is saying that?
Sami, it's a Gulshan.
Gulshan. That's fine, but beyond that also something has to be said. Gulshan, দুজনকেই বলছি, you proceed from there.
Output will be either high or low.
Fine. You next step.
So it will act as a switch.
Next stage.
So if VD is higher, more positive, then value of V2 will be always greater than V1.
That is true. If I have some XY plot like this, how will you explain this plot? How will you describe this plot? When x is at minus infinity, what will be the output value? What will be the y value?
0.
You proceed from there. These are all very basic things. When x is between -1 to -2, what is y?
Y is 1. Then when x is in between -1 to 1, y is 0. Then when x is in between 1 to 2, y is again 1. And then for x...
Fine. Now you try to go for this given plot. Transfer characteristics here. You try to explain this one in the same line.
So when VD is less than 0, it is minus VSAT, and when VD greater than 0, it's plus VSAT.
That's all. For positive VD, output is plus VSAT. For negative VD, output is minus VSAT. And when VD is exactly 0, you cannot say what is the output. Truly speaking, at exactly 0 VD, output should be 0. But as it is now in the linear region and as the noise voltage will be there, so you cannot say that the output is exactly at 0 or the input difference voltage is exactly at 0. But you can, if you can establish that the effective input difference voltage is 0, then the output will definitely be 0. But from this transfer, what we can infer is for positive input difference voltage, the output will be positive saturation voltage level, and for the negative VD voltage, the output will be minus saturation voltage level. So here, probably Gulshan or somebody was saying that the output is basically acting as a switch. The two distinct voltage levels are there. One is the plus saturation voltage level and the other is the minus saturation voltage level. Plus VSAT and the minus VSAT. Depend করছে কিসের উপর? Now whether my VD is positive or negative. If VD is positive, output plus VSAT. If VD is negative, output is minus VSAT. This will be always true for any operation amplifier. You must not forget this. You must not forget that for positive DC, positive input difference voltage, output is plus VSAT. For the negative input difference voltage, output is minus VSAT. Now, what do you mean by the input difference voltage? What do you mean by the input difference voltage? What is the input difference voltage?
V2 minus V1.
Yeah, the difference between the two input terminal potentials. Non-inverting minus inverting. Okay. Now, what is the significance that the input difference voltage is positive? In terms of the
non-inverting greater than inverting.
Yeah. Non-inverting input terminal potential is at a higher level than the inverting input terminal potential. Reverse will be the case when the VD is negative. So now I am connecting two input potentials VA and VB here. I am monitoring the output. If the output is plus VSAT, what will be my inference?
VA greater than VB.
The relative nature of VA and VB?
VA greater than VB.
VA is greater than VB. But if V0 is minus VSAT, what will be my inference?
VB greater than VA.
So that means here, using this circuit and these characteristics, we are basically using this circuit as one voltage comparator and comparing between two input potentials. And depending upon the relative nature of the two input potentials, the output is either plus V set or minus V set. So by observing the output potential, I can readily infer the relative nature of the two input terminal potentials. So this application of the operation amplifier in the is there any feedback here?
No, sir.
No, sir.
Loop configuration. So in this open loop operation, but as one amplifier, it has absolutely got no use. So as amplifier, operation amplifier in open loop has got no use, but in open loop mode, the operation amplifier can be readily used in voltage comparators. So next class
clear আসছে না
স্যার মাঝে একটু কেটে কেটে গেল
আচ্ছা কোন জায়গায় শুনতে পারেন বলতে
এই লাস্ট স্টেটমেন্টটা ওপেন লুপ
আচ্ছা ঠিক আছে this operation amplifier in the open loop mode can be used as one voltage comparator that we have explained. But remember, the operation amplifier in the open loop mode will have absolutely no use as one amplifier. Why?
Because there is almost no linear region.
The linear region is too small. Plus minus 0.1 millivolt. Fraction of a millivolt. Okay, so that's why operation amplifier in the open loop mode cannot be used as one amplifier. But operation amplifier in the open loop has got several applications in the field of voltage comparators. Okay? Clear hoche eta?
Yes, sir.
So in the next class, what we will do is we'll just extend from this particular point, and we'll start from the for several applications of operation amplifier as comparator. কি কি ধরনের application হতে পারে, we'll study those things. But in the meantime, please try to go through the difference amplifier, basics of difference amplifier, because তোমাদের নিজেদের ফিউচারের জন্যই ওটা দরকার.
Okay, sir.
Okay. Mansoor? Mohsin Mansoor?
Present, sir.
Ashish Patro? Absent.
Present, sir. Present, sir. Present, sir.
Fine. Vaibhav?
Present, sir.
Jogesh Tiwari? Jogesh Tiwari? Absent. Mustafa Kamal?
Present, sir.
Suvlin Singh?
Present, sir.
Shikha Shaha?
Present, sir.
Shahwaz Parvez?
Present, sir.
Suraj Mohan Soren? Absent. Brotin Ghosh? Brotin Ghosh? Absent. Shandiporna Burman?
Yes, sir. Present.
Rion Samanto? Absent. Onkit present. Saurabh Sen?
Present, sir.
Sangram Saha? Sagar Chaudhary?
Yes, sir. Present, sir.
Biplab Sarkar?
Yes, sir. Present.
Moinak Das? Moinak Das? Absent. Ayushman Brahmo?
Yes, sir. Present, sir.
Shuddha Satya Goho? Absent. Aniket Ghosh?
Yes, sir. Present, sir.
Udbhash?
Present, sir.
Somojit Acharya present. Arnab Seth?
Present, sir.
Niragho?
Present, sir. Present.
Parvez Mullik present. Ashraf Hossain?
Present, sir.
Sinjoy?
Present, sir.
Yoshi Asgar? Absent. Aryan Sardar? Absent. Anindita present. Pallab Kumar Mondal? Absent. Prosenjit Mondal? Absent Shoham Kanji,
Present, sir.
Shilpa Mondol,
Present, sir.
Anirban Noskor,
Present, sir.
Joydeep Maji present, Shubhajit Mondol,
Present, sir.
Vijul,
Yes, sir.
Mrityunjoy, absent Surjo,
Yes, sir.
Nishant Patel,
Present, sir.
Gulshan Poddar present, Obhirup Kaviraj,
Present, sir.
Ornik, absent Orijit Paik,
Present, sir.
Shomik,
Present, sir.
Rajdeep present, Obhirup Shah,
Present, sir.
Shourjo,
Present, sir.
Sritama,
Present, sir.
Himanish,
Present, sir.
Himanish Pal present, Himanshu Ranjan,
Present, sir.
Biplab, absent Joyita Rai, absent Saptasho,
Present, sir.
Orpon Gayan, absent Obhik Pal,
Present, sir.
Kamal Khara,
Present, sir.
Prosenjit Doripa,
Present, sir.
Nasiruddin, Mohammad Nasiruddin, absent. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
ঠিক আছে